Hi everyone, and welcome back to my science studio. So in this lesson, we're going to learn how to name hydrates. And hydrates are essentially ionic compounds that have a specific number of water molecules attached to them. And you see, that's what this little dot between the ionic compound and the water is telling you. That dot means you're looking at a hydrate. And now, for the most part, hydrates are a specific type of crystal, but we'll talk about that a little later. Okay, so how do we name a hydrate? It's very simple. First, you name the ionic compounds as you normally would. And as a little side note, if you haven't done so already, I highly recommend you check out my video on how to name ionic and covalent compounds. That'll definitely help for learning this lesson. Then once you do, you're going to add the hydrate part at the end of it. So let's walk through an example. First, we're going to name the ionic compounds. In LiCl, lithium is the metal and chlorine is the nonmetal. So what you're going to do is that you're going to take the second name, chlorine, and you're going to drop the ending and change it to "ide." So we get lithium chloride. And remember, we do not use prefixes when naming ionic compounds. So there's no mono, no di, no tri. That's only when you're naming covalent compounds. And because lithium has a fixed +1 charge, right? It's in group 1A of the periodic table and will always be a +1. We do not need to write a Roman numeral here. So the ionic compound is simply lithium chloride. Now this compound is a hydrate. That's what the H2O is telling us. So we're going to add the word hydrate at the end. But before we do that, we need to count how many water molecules there are. You see, the coefficient in front of the H2O, so the number in front, is a 2. And the prefix for 2 is di. So the full name becomes lithium chloride dihydrate. And again, notice, even though we do not use prefixes for ionic compounds like lithium chloride, we do use prefixes for the hydrate portion. So again, it's not lithium monochloride, it's lithium chloride dihydrate. Let's try this next one. Cd is cadmium, and cadmium is one of those transition metals that actually has a fixed charge. It's always going to be a +2. So again, you do not need to add a Roman numeral to the name in order to denote the charge. We know that cadmium will always be a +2. Now, Br comes from bromine. So for the second name, again, we drop the ending and change it to "ide." So putting it together, we get cadmium bromide. But now we look at the water. There are 3 water molecules, right? So the prefix for 3 is tri. So the full name for this hydrate is cadmium bromide trihydrate. Now let's try 2 examples where we are given the name and we need to write the formula. So for this one, calcium sulfate pentahydrate. Okay, so calcium has a +2 charge and it's fixed. Remember, it's in group 2A of the periodic table and will always have a +2 charge. That's why they didn't need to write a Roman numeral here next to the calcium in the name itself, because it's always going to be +2. But anyways, then sulfate, we recognize it as an oxyanion with the formula SO4 with a -2 charge. And if you haven't done so already, I highly recommend you check out my video on naming oxyacids and oxyanions. That lesson could definitely help you with this one. But anyways, so what we're going to do is that we're going to cross the charges. So the +2 and the -2 will cross over. But since they're both a 2, what we're going to do is that we're going to divide by their greatest common factor, which is 2. And this rule, by the way, applies to if you have a 2 and a 2, or a 2 and a 4, a 2 and a 6. So anytime you have an even number. If you have 2 odd numbers, it will not work. So just as a little tip for you guys. But anyway, so once we divide both by 2, this gives us a 1-to-1 ratio. So the ionic compounds becomes CaSO4. And because we only have one sulfate, we do not need to add a parentheses. Remember, you only add a parentheses around a polyatomic ion that's within a compound when the charge that you dropped becomes a subscript greater than 1. And so in this example, even though you technically dropped a 2, which is greater than 1, because it's simplified to a 1-to-1 ratio, in other words, for every 1 calcium, you have 1 sulfate present, you do not need to add a parentheses around the sulfate. It's implied that there's only 1 sulfate ion present. Now, the second part of the formula is pentahydrate, which means there are 5 water molecules. Think about your shapes. A pentagon has 5 sides, so penta means 5. So the full formula is CaSO4 with his little dot, 5 H2Os. And again, the dot tells you that the water is bound to the compound. It tells you that it's a hydrate. Now let's try this last example. So sodium carbonate decahydrate. Sodium is Na+, right? It's in group 1 of the periodic table and will always have a +1 charge. It's fixed. And carbonate is another oxyanion, and it has the formula CO3 to the -2 charge. So when we cross the plus charge from the sodium and the -2 charge from the carbonate, we end up getting Na subscript 2 CO3. And again, we don't need to add a parentheses here because the carbonate only appears once. Now, deca in decahydrate means 10. So we are going to attach 10 water molecules. So putting it together, we get Na2CO3, this little dot, 10 H2O. And just for fun, this compound is actually the active ingredient in washing soda. So if you've ever used washing soda for doing your laundry, you've used a hydrate. Its active ingredient is sodium carbonate decahydrate. And guys, at the end of the day, hydrates are a specific type of crystal. So some other common examples include gypsum, which is the main constituent in many forms of sidewalk chalk, plaster, drywall, etc. And copper sulfate pentahydrate is one of my faves. It's actually a really fun one that you may have seen in the lab. It's that bright blue crystal. And guys, one more thing to remember about hydrates is that the water molecules in the hydrate can be driven off by heat. So for example, if you heat copper sulfate pentahydrate in, let's say, a lab oven, the water molecules are removed, right? They're dehydrated and you're left with the anhydrous or dehydrated compound, which is just copper sulfate with no water molecules attached. And that concludes my nomenclature series. I'm strongly considering adding one more video in the future on acid salts and acid anions, so if that's something you'd like to know how to name, please feel free to drop a comment below. Thank you guys so much for watching. If you found this lesson helpful at all, please don't hesitate to like and subscribe. In the meantime, stay tuned for our next series where we'll start learning about what chemical reactions are, how to balance reactions, and how to predict the products. But until then, happy studying!